So once you've separated and are looking just at the one specific mass to charge ratio that you're interested in, we're going to need to detect it. And so we have ions that are going to come into the detector, and we need to generate either a current or a voltage, and we'll actually generate a current that we can then easily convert to a voltage. So we need an electron multiplier. There's a couple flavors of this, but the first step in both of them is to take your ion and make it into an electron. And so the way that we do that is, this is very similar to how it works with a PMT, where you have your ions coming in the entrance slit, and then they impact a cathode. And when they impact the cathode, then electrons are liberated. The next step is electron multiplication, and so which is very similar again to a photomultiplier tube, where you have electrons that have been liberated from the ion impacting the cathode, that then multiply through the diodes that are held at progressively more and more positive potentials. And so, you know, we have 2 here, we have 6 here, we have more than that here, 18, and then many by the time they get to the anode. And so I've drawn it in a relatively simplistic way, but you can end up with 10 to the 5th multiplication. And so then at the anode, the current, all of these electrons are collected, it generates a current, and we can easily convert that current to a voltage, which we can easily measure. So we're basically measuring the number of ions based on the current that we measure. A channeltron works really similarly to the other electron multiplication methods, except for that it has an external way of converting ions into electrons. And so electrons come into the channeltron, which stands for continuous diode electron multiplication, so it doesn't have discrete diodes like we've seen before. Instead, it has this lead-doped glass, and so every time an electron impacts the wall, then you have electron multiplication. And instead of having discrete diodes held at different voltages, you have the mouth of the channeltron being held at something like -2 keV down to ground, which is more positive, so the electrons want to travel deeper into the channeltron as they get multiplied, and you have more and more electrons liberated. And so then by the time you get to the anode, you have 10 to the 5th amplification of electrons, which are collected as a current, and then you can easily convert that current to a voltage, which you can measure. And so that's how a channeltron detects ions coming from a mass spec.